Good morning. Today, I will present an analysis demonstrating that human-caused wolf mortality persisted for years after the discontinuation of hunting following Minnesota's 2012 to 2014 seasons. This presentation also exemplifies what can be achieved through the application of appropriate statistical analysis. Page 2. Let me start with a brief summary of the findings. The Minnesota Department of Natural Resources collected wolf radio telemetry data from 2004 to 2019, which encompasses the period of the wolf hunting seasons of 2012 to 2014. Statistical analysis of this data revealed that wolf annual mortality remained nearly constant at 21.7% from 2004 until the initiation of the hunt. Mortality then doubled to 43.4% with the start of the first hunting and trapping season in 2012, and remained at this elevated level even after hunting was discontinued in 2014, through year 2019, the last full year in the dataset. Page 3. First, a historical overview is in order. In the 1950s, only 450 to 700 wolves remained in northern Minnesota. The Endangered Species Act of 1973 placed wolves under protection, allowing their population to gradually increase. By the winter of 2004, the population peaked at 3,020 wolves, the highest number on record, and has remained below that level ever since. Thus, the wolf population stabilized in the early 2000s. In December 2011, the U.S. Fish and Wildlife Service removed wolves in the western Great Lakes region from the federal endangered species list. One might have hoped that the Department of Natural Resources, DNR, would leave well enough alone. Yet Minnesota and other state DNRs introduced hunting and trapping seasons in 2012. Hunting and trapping resulted in the deaths of 413 wolves in 2012 to 2013, 238 wolves in 2013 to 2014, and 264 wolves in 2014. In December 2014, a federal judge placed wolves back on the endangered species list, observing the state's DNR's inability to protect the wolf populations. Page 4. A 2022 study titled Recent Trends in Survival and Mortality of Wolves in Minnesota, United States by Chakraborty et al. Summarized their findings as follows. We did not observe evidence that survival was markedly reduced during years when a regulated hunting and trapping season was implemented for wolves, years 2012 to 2014. However, cause-specific mortality analysis indicated that most mortality was human-caused. Additional notable statistics from this study were: wolves' yearly mortality in 2004 was estimated at 13.2%, corresponding to a survival rate of 86.8%. Yearly mortality increased to 35.3%, with a survival rate of 64.7% in 2012. Wolves' yearly mortality further increased to 43.3% in 2019, corresponding to a survival rate of 56.7%. The figure shows that the change in survival and mortality occurred in a smooth trend. Yearly survival statistics measure the proportion of individuals alive after a 12-month period, while mortality statistics measure the proportion of deaths in a population over the same period. Essentially, mortality is equal to 100% minus survival. Page 5. It was puzzling that while about 20% of the wolf population was accounted for as killed in hunting and trapping season in 2012 to 2013, the Chakraborty et al. Statistics did not observe a marked reduction in survival. The study authors emphasized that, although estimates of annual or seasonal survival rate can provide important information for management, awareness of any temporal trend in survival can be crucial for policy formulation. I decided to analyze this data and requested it from the authors of the paper. Chakraborty kindly provided me with the DNR data used for their analysis. I found that linear regression with the same data resulted in identical trend lines and similar 95% confidence intervals. On the left is the graph from Chakraborty et al., and on the right is the graph from my paper, slightly flattened so the vertical scales match. Notably, the data points on my graph are the raw annual survival data points by calendar year, the same data used in Chakraborty et al. It is also worth noting that data point weights vary throughout the collection. The years 2004 and 2005 did not see any wolf mortality. I will not delve deeper into this as it would be too technical for this presentation. Page 6. Next, because wolf hunts started in mid-November 2012 and in the years thereafter, I renormalized the linear regression for 12-month periods starting on November 1st each year. As you can see, the trend line has not changed. However, we can now see two distinct groupings of data points: higher survival before the hunts and lower survival after the hunts. It is also notable that when analyzing data by calendar years, the partial mortality at the end of 2012 smoothed out the transition of the trend from the pre-hunt to the during and after hunt periods. Page 7. The best way to analyze data like this is to perform a regression discontinuity analysis. For our purposes, regression discontinuity analysis examines a trend before and after a specific event, such as a natural disaster or medical treatment. The trend may change or experience a jump, with the slope either remaining the same or changing after the event, which is technically called the cut point or cutoff. Page 8. Regression discontinuity analysis found a significant trend cutoff around November 2012. The table here shows the p-value, or the probability of the null hypothesis, absence of trend discontinuity, for each month from 2010 through 2014. This analysis recursively tests for cut points month by month, and p-values indicate the probability of the null hypothesis. We see high p-values for all tested cut points, indicating an absence of trend discontinuity, except for the months of October, November, and December 2012, where the p-values are below the significance threshold of 0.05. The number in parentheses represents the wolf mortality jump at the cut point, and regression discontinuity analysis provides us with slopes on both sides of the cut point. Similar analysis did not find a cut point after the discontinuation of hunting and trapping following December 2014. Page 9. The resulting trends are demonstrated in the central plot, while the left and right plots illustrate the absence of discontinuity at other times, such as a year earlier or later. Wolf mortality remained relatively constant from 2004 until the initiation of the hunt. With the start of the first hunting and trapping season in 2012, mortality doubled and then remained at a nearly constant elevated level through 2019. Average annual wolf mortality increased from 21.7% before the hunting seasons to 43.4%. Page 10. Regression discontinuity analysis demonstrated that wolf survival was significantly reduced during and following Minnesota's hunting and trapping seasons of 2012 to 2014. Page 11. As I mentioned earlier, calculations are most tractable in abstract survival units and are better understood in terms of yearly mortality. Thus, on the left plot, we see survival dropping from 78.3% before wolf hunting to 56.6% during and after the hunts. This corresponds on the right plot to an increase in annual wolf mortality from 21.7% before the hunts to 43.4% during and after the hunts, continuing through the end of the dataset in 2019. Page 12. The Minnesota DNR radiotelemetry data contained a wealth of information, allowing to calculate wolf mortality and survival statistics by age and sex. Similar patterns were observed in all wolf groups before and after the hunts. Page 13. This DNR information allowed us to analyze mortality by human and natural causes. On the left side, we see our previous overall yearly mortality. The fine-grained statistical trend in the right plot indicates that human-caused mortality increased sharply during the hunting seasons, while natural mortality initially dropped. Average annual wolf mortality before the wolf hunting seasons was composed almost equally of 10% by human causes and 11.7% by natural causes. With the initiation of the hunts, mortality jumped to an average of 35.8% by human causes and 7.6% by natural causes, adding up to 43.4% of yearly wolf mortality. Page 14. Let me summarize it again. The Minnesota Department of Natural Resources collected wolf radiotelemetry data for the years 2004 to 2019. Statistical analysis showed that wolf mortality remained close to constant from 2004 until the initiation of the hunt. Mortality then doubled with the start of the first hunting and trapping season in 2012, remaining at a nearly constant elevated level through 2019. Notably, average annual wolf mortality increased from 21.7% before the wolf hunting seasons 10% by human causes and 11.7% by natural causes, to 43.4%, 35.8% by human causes and 7.6% by natural causes. The fine-grained statistical trend indicates that human-caused mortality increased sharply during the hunting seasons, while natural mortality initially dropped. After the hunt's discontinuation, human-caused mortality remained higher than prior to the hunting seasons throughout the 5 years of available post-hunt radiotelemetry data. Page 15. Recent studies, including those by participants in this symposium, have demonstrated that wolf survival has become more difficult due to increased human activity, housing, and road density. The continuation of high human-caused wolf mortality after the discontinuation of hunting indicates a change in attitude toward wolves. A recent example can be found in a Star Tribune article from October 3rd, where Minnesotan Brady Harth illegally killed a protected gray wolf and other animals, bragging about his conquests. The wolf population in Minnesota remains stable around 2,500 to 3,000. However, the quality of the wolf population has diminished compared to before the 2012 to 2014 hunting seasons, with smaller pack sizes consisting of younger wolves. My study shows a doubling of annual wolf mortality between 2004 and 2019. Chakraborty et al., 2022, report an even more extreme threefold increase in annual mortality. Neither of these statistical trends supports the reintroduction of wolf hunting seasons. I have heard so many inspiring talks over the past couple of days. You all do so many things right and work tirelessly to learn about wolves and their role in the ecology. The only thing left is for all of us to get on the same page in realizing that further wolf hunting and trapping seasons are unnecessary and harmful. Thank you.